Hey guys, today we're going to look at part 2 of our lesson 1.3. So we're talking about our key elements of experimental design. Our 4 key elements are control, randomization, sample size, and replication. Control. You control for effects other than the one being measured. So something we talked about in our last lesson was confounding variables. So that's something that control helps you fight against. Confounding variables occur when experimenters cannot tell the difference between the effects of different factors on a variable. So an example of this is a coffee shop owner remodels her shop at the same time a nearby mall has its grand opening. If business at the coffee shop increases, it cannot be determined whether it's because of the remodeling or the new mall. We also have the placebo effect that we have to use control to fight against. The placebo effect is when a subject reacts favorably to a placebo when in fact he or she has been given no medical treatment at all. So some ways to assert control and work against the placebo effect are blinding. Blinding is a technique where the subject does not know whether he or she is receiving a treatment or a placebo. Double blinding is an experiment technique where neither the subject nor the experimenter know if the subject is receiving the treatment or the placebo. The way that blinding and double blinding helps is that if both the subject nor the experimenter or just the subject, if they don't know if they're getting the placebo, then you're just letting the effects naturally happen and not creating that favorable outcome on purpose. Our next element is randomization. Randomization is a process of randomly assigning subjects to different treatment groups. Completely randomized design, subjects are assigned to different treatment groups through random selection. Our first example is randomized block design. Divide subjects with similar characteristics into blocks, and then within each block, randomly assign subjects to treatment groups. So if we look here at our example, all subjects are broken up into their age groups. So we're testing the effects of a new weight loss drink and divided the subjects into age categories. So we've got 30 to 39, 40 to 49, and over 50. And then within each of those groups, they're randomly assigned to either the control or the treatment. So some from each block have the control and some have the treatment. Randomized block design at the school, that would look like, one way to do that would be to break it up into freshmen, sophomores, juniors, and seniors. So we have the whole school breaking up into those 4 blocks. And then randomly, some freshmen would get the control, some would get the treatment. Some sophomores would get the control, some would get the treatment. Some juniors control and treatment, some seniors control and treatment. Our next type of randomization is matched pair design. Subjects are paired up according to a similarity. One subject in the pair is randomly selected to receive one treatment, while the other subject receives a different treatment. So a way that we could do this at school is you could pair 2 students up by having the same schedule, so like same classes, and one would get the control and one would get the treatment. You could pair them up by the same GPA. One would get control, one would get treatment. You could pair them up by the same age. One would get control, one would get treatment. Okay, so there's lots of different similarities that you can choose, and you kind of want to base it on what your experiment's about. Our next element is sample size. The number of subjects in a study is very important to the experimental design. To test a vaccine against a strain of influenza, 10,000 people are given the vaccine, and another 10,000 people are given a placebo. Because of the sample size, the effectiveness of the vaccine would most likely be observed. So since we had that large sample size, we have a more effective study. And then replication is the repetition of an experiment using a large group. So the experiment for the vaccine against a strain of influenza is repeated with a different sample of 10,000 people for the treatment and 10,000 for the control. So again, you have that large sample size used in the replication. The reason we use that replication is if you get those same results, that makes your study even stronger. So our example, a company wants to test the effectiveness of a new gum developed to help people quit smoking. Identify a potential problem with the given experimental design and suggest a way to improve it. The company identifies 1,000 adults who are heavy smokers. The subjects are divided into blocks according to gender. So one block is men, one block is women. And one of the blocks is control. After 2 months, the female group has a significant number of subjects who have quit smoking. So our problem with this experiment is that the groups don't have similarities. So our blocks don't have similarities. Okay. So gum might affect women and not men. Okay, so a way to fix that would be to use a randomized block design. So if you break it up into men and women, and then you give some of the men the control and some the gum, give some of the women the control and some the gum, you're going to have a much better study. Okay, then we're going to look a little bit into our sampling techniques. When you're talking about sampling techniques, you're focusing mostly on random sampling. So a random sample, every member of the population has an equal chance of being selected. And a simple random sample, every possible sample of the same size has the same chance of being selected. So that's our first sampling technique, the simple random sample. Random numbers can be generated by using a random number table, a software program, or a calculator. You assign a number to each member of the population, and members of the population that correspond to these numbers become members of the sample. So if you have the whole school and you have everyone's got their ID number. So if you did a random number generator and randomly selected 40 student ID numbers, that would be a simple random sample. So simple random sample, there are 731 students currently enrolled in a statistics at your school. You wish to form a sample of 8 students to answer some survey questions. Select the students who will belong to the simple random sample. So how to create random integers in a calculator. First, you have to seed your calculator. So to seed your calculator, you type your student ID number, then hit stow, then math prob 1. Okay, and then you get out of that and you want to clear your calculator, and then math prob 8. Your lower is the lowest value you want, your upper is the highest value that you want, and n is your sample size, the number that you want. So in this case, our lower would be 1, our upper would be 731, and we want 8. And then our calculator would give us 8 random numbers. Next, we have stratified sample. Divide a population into groups, strata, and select a random sample from each group. To collect a stratified sample of the number of people who live in Westridge County households, you could divide the household into socioeconomic levels, and then randomly select households from each level. So for a stratified sample, you break it up into groups by similarities. and then you take some from each group. Cluster sample. It's similar to our strata, but it's different. You divide the population into groups called clusters, and you select all the members of one or more clusters, but not all of the clusters. So in the Westridge County example, you could divide the households into clusters according to zip codes, then select all of the households in one or more, but not all of the zip codes. So here they chose zone 1, so that would be their cluster sample. They could choose another one, zone 4, and take both of those, every member in both of those zones, and create their sample. Then we have our systematic sample, choosing a starting value at random, then choose every kth member of the population. So in the Westridge County example, you could assign a different number to each household, then randomly choose a starting number, and then select every third household. So here they randomly started with house 2, and then they did every third household. Okay, and that would make up their sample until they got to the end of the line. We also have a convenient sample. This is not a random sampling technique. This is you choose only members of the population that are easy to get to. This often leads to bias studies, and it is not recommended. So our last slide, identify sampling techniques. You are doing a study to determine the opinion of students at your school regarding favorite pizza places in Frisco. Identify the sampling techniques used. So take a minute, read both of these questions, pause, find your answers, and come back for the correct answers. Okay, hopefully you get a chance to try those questions. Number 1, you divide the student population with respect to grade level and randomly select and question some students in each grade level. So you took some of the students from each of those groups that you created. That is a stratified sample. 2, you assign each student a number and generate random numbers. You then question each student whose number is randomly selected. So that generate random numbers tells you you're going to do a simple random sample.